Nanoparticle Gold is fantastic for boosting physical and mental health and giving you energy. In this video, we're going to explore the 3 different ways that we can make Nanoparticle Gold and the advantages and disadvantages of each way. Now, whether you are a maker of gold or you are a user of gold, you're going to want to watch this video because you're going to learn things that you did not know before. There are 3 methods of making gold nanoparticles. Ruby red with low voltage electrolysis, rose gold using plasma arc, and laser gold. Now, until recently, easy way of making gold nanoparticles was with ruby red low voltage electrolysis. But there's a history here with this I want to cover. Our story begins in ancient Egypt. Electrum. We've talked about electrum before. Somehow the ancient Egyptians took electrum, which was about 60% gold, and turned it into some kind of health rejuvenating drink. Now, it's unclear whether their substance was nanoparticles or not. I tend to think it was, and that the process was lost. So now we move forward in history to medieval alchemy. This is where they tried to recreate the electrum of the past, but of course they didn't know how they did it. A alchemist came up with a way of breaking down gold using chemicals and creating a substance called gold chloride. And while this had the effects that it wanted it to have, it winds up that gold chloride is a neurotoxin. And if you take too much of it, it's not so good for the body. So that ends the gold chloride thing for a while until we come up to, in the early 1950s, a chemist named Turkovich figured out a way to take the gold chloride and turn it into nanoparticles. It was a really crude method, but it did work, and it did limit the amount of gold chloride that was created in the process. This really didn't take off too well until 1970s, when a modern chemist looked at this formula and revamped it and turned it into what we have today, which is ruby red gold with low voltage electrolysis. Now, the process still uses the basic form of breaking the gold down into gold chloride, and then the gold chloride is transformed into nanoparticles. Basically, it's like a machine being stuffed in. You stuff the gold chloride in, and then when it can't fit any more gold chloride in the solution, what you get stuffed out is the nanoparticles. But when you turn the process off, you still have some gold chloride left in the substance. Not all of the gold chloride is used up. It can never be used up because it's a gold chloride in and nanoparticle substance out. I'll save you the boring math on it, on how much gold chloride is left in your ruby red after you're done with it. Basically, it can vary between 1% to 10% of the solution. So if we take the high end of the solution, it comes out to about 162 micrograms of gold chloride in a teaspoon that could be left over. Now, if you want to put that in perspective, at one time, rheumatoid arthritis was treated with gold chloride before they had anything else to treat it with. The daily dosage of that was about 5 to 8 milligrams a day. When better practices came out, they abandoned the gold chloride for other arthritic medicine that was not as toxic. Out of all 3 methods, ruby red winds up being the one that uses the most amount of gold material in the process to create the least amount of colloidal nanoparticles. To be honest, when you look at it in the microscope, the ruby red process is weird. It is different than other nanoparticle substances where you can clearly see the nanoparticles floating around in there. So speculation is that we're looking at probably a 10 parts per million solution of ruby red nanoparticles using 8 milligrams of gold. Now, the plasma arc process of gold doesn't create any gold chloride whatsoever. It's extremely efficient. It will use 2 milligrams of gold and produce 20 parts per million or more of nanoparticles. And the waveform is typical for what it's supposed to look like when you have nanoparticle solution in there. Now we come to the latest method of making gold nanoparticles, and that's with the laser. The laser becomes the most efficient way of making nanoparticles. It comes in as using 300 micrograms of material and producing 20, 30, or 40 parts per million gold nanoparticles. And it doesn't create any gold chloride either. Uses just distilled water. Its waveform is similar as what nanoparticles are supposed to look like. And there's even an extra caveat that I just discovered with laser gold. It's highly likely that when we use the laser on gold, we are creating what's called gold nanostars. Typically, gold nanoparticles are spherical. They can come in other shapes and sizes too, especially if they're made chemically. But gold nanostars may have additional health benefits that the spherical nanoparticles don't have. For one thing, the shape of it is pointy instead of round. And it's theorized that the points give off near-infrared light in the body, which then neutralizes a lot of not-so-nice things in the body. They're even trying to adapt these gold nanostars to fight cancer. So it's possible that when making our colloidal gold with the laser, we're actually making a superior gold. Not to mention that the nanoparticle size in the laser is around 5 nanometers, as opposed to colloidal gold with the plasma arc, which is about 20 nanometers, and the low voltage DC is also about a 20 nanometer size if we're looking at the red variety of the nanoparticles. I find the idea intriguing that with the laser we may be making gold nanostars, and I'm going to investigate that in the future, and I'm going to have a show dedicated to that because I'm pretty certain that we are, and I'll explain that in a later show. But in the meantime, let's back to this show, is which one do you want to make for yourself? And that's a personal choice. And each one carries with it its good and its bad. Low voltage DC with our nice bright ruby red color produces the least amount of nanoparticles, but it also comes with gold chloride. Plasma arc is a better solution because there's no gold chloride in it, but it needs 10 to 15,000 volts of electricity to do it. Not easily accessible for your average person. It makes low voltage DC a better option for people with limited skills. Laser means you have to invest in a laser. Now, laser engravers are coming down in price. It's not as easily made because we're talking about smaller amounts of materials, roughly making 50 milliliters of material at a time, taking maybe anywhere from 20 to 40 minutes. So the amount of material that you can make with the laser is limited. Of course, you're going to be looking at the 5 nanometer size we're using the laser, whereas in the others, we're looking at 20 nanometer size. And the laser has the gold nanostars. That is really exciting. So whether you're making your own gold nanoparticles or you're buying your own nanoparticles, I hope this show has informed you so that you know what you're buying or making before you do it. And the choice, again, is up to you.